Hello, everyone. Happy Wednesday. It's the middle of the week. So for those of you who don't know me, my name is Nick. I lead the data science and machine learning function for safety and customer care at Lyft. And my team has been building AI Assist, which is our customer care AI agent product for the last couple of years. And I'm here to talk to you about how we built an eval system that actually helps us scale AI agent in production. So maybe just a quick show of hands, how many of you here ship agent without evals? I'm literally guilty of that, so don't be embarrassed. I know it's one of those things that we always forgot about, but really shouldn't. Hopefully, Lyft doesn't need any additional introductions. Hopefully, everyone in the circle knows Lyft, but just a couple of statistics about Lyft. We have 79 million trips per month, and our AI Assist chatbot today serves about 270,000 AI interactions per month. We've been able to build 7 AI agents and more in productions. Our deflection rate is 65%, and AI resolution rate is at 35%. 35% might seem a little bit low, but we really hold ourselves to a really high bar. We want the agents to solve the customer issue fully end-to-end and not just block customer from reaching support. I'm sure you all have experience with that with support chatbot. So I'm going to quickly walk you through AI Assist journey. We started this journey in 2024. We used very simple deterministic logic back then. So imagine if you say A, the bot is going to say B back to you. But we all know how LLM has really transformed the space. And with eval, we have been able to build more than 7 AI agents in the past. And our resolution rate has really gone up from 10% to 35% and climbing. Just to give you a sense of what type of AI agent we're building at Lyft, for rider, we have agent that handle charges dispute, unpleasant experience. If you ever have a Lyft driver that smoked weed in the car, you can report to us. On the driver's side, we have automated damage claim processing, compliance status, yada yada, taxes. We love doing that. I also just want to show a couple of really agents that I thought was really interesting that we built. And also shout out to Akshay and Nasutan, they're probably down here, who actually on my team who built this AI agent. We have this agent on the driver's side that is a multimodal complex AI agent that when driver upload photos of their damage claim, we get back to them in 15 minutes for claim decisions. On the rider side, we have an agent that literally processes 80+ automation rule or refund logic in the back end and able to, contextually based on what the rider is telling us and what their situations are, explain our refund decision to them in a very seamless way. And all that is to say is, we wouldn't have been able to ship so many AI agents or test and make sure that such complex AI agents actually perform in productions, right, without a great eval system. So those of you who ship agent without eval, reading that decisions. Cool. So I'm not going to walk you through AI Assist architecture. It's LangChain, LangGraph, LangSmith, some NCP and all that. But I'm more interested to talk to you about how we think about AI Assist eval, or how you should build eval for your production system, right? A little bit about myself. I've been, for the longest, for my career, I have been doing data science all the while. I've been, building machine learning model. And my approach to think about AI eval for AI agent is no different than traditional ML evaluations. So for those of you who come from data science background or ML engineering background, you're used to working in the notebook. You develop this model, you train on a huge data set, you have some kind of ground truth for regressions or classification tasks, and then you will run this offline evaluation, right, and see what the performance are. Should we ship? Should we not ship? think about this as a quality gate, right? Can we launch? So I really want to emphasize on that offline eval piece. If that has been the way that we do ML engineering for the last couple of years, why should AI engineering be any different, right? So really think about that. And the offline eval really serves as a quality gate. You don't want to use your user as test data. But maybe if you're a startup, you have 5 customers, maybe that's okay. But at the level scale, at the scale of Lyft, we really don't want to use our customer as test data. And once we got the agent in productions, we have continuous monitoring. We have our online eval, getting all the LangSmith traces, human in the loop, all that good stuff. That's giving us feedback on how to improve the AI agents. So I'm going to go into each of these components in a little bit more details. Thinking about offline evaluation, right? What does that mean? How is that different from traditional ML engineering workflow? We love working in notebook. We love just slapping on the CSV file and then get a ground truth, right? But for AI engineering, it's a little bit more setup there. We really took inspiration from TauBench, which the fantastic team at Sierra AI has published as a public benchmark that all the other LLM model, all the other AI labs are using as a benchmark. So for this offline evaluations pipeline, we built a lightweight simulator. So on the right here, we have our LangGraph agent, which is the AI agent that we built for AI Assist. And then we have a LLM user, or we just use one of the out-of-the-box LLM model to role-play a user so that we can generate this end-to-end trajectory of an interactions, right? And then we use a very config-driven approach. We have a YAML file that specify what the user intents are, what is the support scenarios that we are looking at, how do we mock the state of the world. Because in offline, you're not calling, you're making network call to other MCP. So in offline setting, we're mocking those MCP output. And imagine if an agent call a tool offline, we sort of just mock the MCP output with one of the things that's on the config file. So we've got this long chain of trajectory. On the permuted, so our config it's a permutations of a combination of different things, right? The state of the world, the user intent, user persona, and all of that. And the goal here really is to get a diverse data set that you can use to approximate production data, right? You want your offline eval to be a good proxy of how your agent is going to perform when you actually turn it on. So for the trajectory, we also define evaluator, LLM. We use LLM-as-a-judge. I think everyone is doing that. Code assertion, we run some very simple Python script that checks the end state of the world to see if certain condition is met to define success or failure. I'll get into LLM-judge a little bit more. I think when we started thinking about LLM-judge, and I'm sure everyone here has looked into LangSmith or any other observability platform, you see different platform or framework comes with a pre-built set of LLM-judge, right? Things like toxicity score, response helpfulness, conversation conciseness, and things like that. And we kind of started the same way as well. We were defining things like tool use appropriateness, response helpfulness, naturalness, and all that, right? And these are being scored on the scale of 0 to 1, so like a scalar metrics. So what's the problem with this, right? For response helpfulness, for example, what does a 0.4 score means compared to 0.7, right? What does that mean? How can you move the needle, right? And if you want to move your overall score, what product insight is this giving you? So we've been very opinionated about what LLM-judge should do. And hopefully, no one's using toxicity score or helpfulness agent in productions. So the way that we think about LLM-judge is that it should be framed around the task that you want your AI agent to perform, right? So your AI agent is being instructed to do tasks A, B, and C, and each of those tasks has their own success and failure criteria. So a very simple example that I pulled from our LangSmith platform is this educational rubric. So one of the tasks that we want our AI agent to do is to educate the user about Lyft policy around rider chargers or some other type of support scenario, right? So the benefit of doing this is you're defining very clear success criteria for your agent, and by default, defining a rubric like this, when you see interaction that fail your rubric, you can very quickly know like what are some of the common failure mode, right? And that becomes actionable insight, that becomes product insight to help your tech team, your engineering team to improve your AI agent, tweak a prompt, tweak a tool, change your control flow logic or whatnot, and then you run the loop again and see if it improved. So this is just another rubric that I want to quickly show as well. Okay, another thing that we really struggle with is, how do we trust this LLM as a judge, right? Like we define a rubric, we define some prompt, but how do we know it's doing the right thing? So my own personal take is that, well, you just train an LLM judge like a machine learning model, right? You collect some human label ground truth from your domain expert about how to score a certain interaction based on a rubric. And you go through this traditional ML engineering loop, change a prompt, change your reasoning, see if it aligns with your human agreement score. And then if it does, then you have a LLM judge that's aligned with human judgment. So in our little offline simulator, what else can go wrong, right? I spoke very earlier about we used a out-of-the-shelf Claude model, OpenAI model to role play as a user. But oftentimes what we see is, as you can see here, the LLMs are being nice, helpful assistant. They explain their issues very nicely to our AI agent, but I'm guilty of this as well. I don't typically do this when I reach out to support. Most often than not, what the user verbatim we see in productions are like 1 or 2 words, right? People are very impatient. People don't sit down and nicely explain their issues. So when we did this, our first AI agent was giving us 90% pass rate. Nice, we can launch, right? But it's a rude awakening for us when we actually launch the productions. So what can we do to fix this, right? This is a pretty active research area as well. Microsoft published a paper about this, how you should be training your LLM user using real-world verbatim, right? So this is essentially what we are planning to do at Lyft as well. We're actively looking into fine-tuning a custom LLM model that's aligned with our Lyft user verbatim, so they speak more like our user. Technically making our eval a little bit more difficult. Your benchmark score might go down. But you really want this to be a good proxy for production, right? Otherwise, what's the point of this? Another thing that we are looking to work with our UXR team on is defining clear user personas, right? And this will be used to ground our LLM model to behave more like a Lyft user. All right. I want to quickly talk about how LangSmith really helps us manage our eval workflow. Tracing, evaluator setup, automation, annotation queue. If you're here, you're probably familiar with LangSmith. I'll just quickly speak through this because I'm running out of time. Tracing, I think this one has been brought up multiple times in previous presentations, but with our offline simulation and our online runs in productions, we're using LangSmith to help us capture these nice trajectory. This become really nice training data for our model later on, as well as a good interface for our operation team who is manually annotating our data. evaluator, this is how we build our LLM-judge that we use for our offline simulator as well as for production monitoring. Annotation queue, like one of the nice things about LangSmith is that we have automation in LangSmith. So for traces that fail your LLM-judge criteria, we can set out an automation, and that adds the failed traces to an annotation queue. And here we have our operation team set up on this annotation queue to help us manually label these examples. Our engineer will go in and analyze what are the systematic failure mode, and that feeds back into how we improve our AI agents. All right, so what's next for AI Assist, right? We've done a lot of agent engineering. That means like managing the context, so managing harness, right? I think that's the shiniest horse in town nowadays. Managing the harness around the model, which is basically everything around the model, whether that's the RAG pipeline, tools definitions, graph, system prompt, and all that. And we've been running our offline simulator as more of like a lightweight script offline. And now there's the concept of an eval harness that we can define, that can help us manage our evaluation run offline more effectively. And thus, so far, for all the traces that we've been collecting so far, we've been using it to feed into product insight that help us improve our agent, improve our harness. But we haven't really done much on model training, updating the weight of the LLM model, and train a custom LLM for AI Assist. So that is also one active area that my team is looking into. So that's how we close the loop on the eval pipeline. All right. Thank you, everyone.